of Chemical Engineering Division Board, we are organizing the webinar on the theme climate change and microbes. So for the last few months, IAI West Bengal State Center is organizing a series of online lectures on the very pertinent topic of today, that is climate change. So we have covered different angles, different perspectives, right from effect of climate change on the energy transition, net zero, COP26 commitment made by the Indian government, and now there is a big shift and effect of microbes and on the climate change. So, am I audible?
Yes. Please carry on.
Okay.
Yes.
So, effect of climate change, effect of microbes on the climate change, and we are our very distinguished speaker, Professor Nitosh Kumar Brahmo, who will be delivering on this subject. Prior to that, I would request the chairman of West Bengal State Center, Dr. Nirmal Das, to kindly deliver the welcome address to the audience. Over to you, sir.
Thank you, anyone. Am I audible?
Yes.
Well, good evening and a very welcome to all the dignitaries on this webinar. Dr. Hemant Thakre, President of IAI, Engineer Sandeep Kumar Dev, Vice President of IAI, Professor Dr. Shilpa Tripathi, Chairperson, Chemical Engineering Division Board, Dr. G. Ranganathan, Chairman, Committee of Advancement of Technology and Engineering, IAI, Honorary Secretary Dr. Raju Bosak, Mr. Anirban Dotto, Joint Honorary Secretary of West Bengal State Center and today's moderator, and today's eminent panel speaker, Professor Nitosh Kumar Brahmo, who happens to be the immediate past Honorary Secretary and Chairman of Chemical Engineering Division of Subcommittee, West Bengal State Center, Council members, corporate members, ladies and gentlemen, and dear students. Today, on the occasion of the evening lecture on the topic climate change and microbes, organized by the Chemical Engineering Division of West Bengal State Center, let me extend a warm welcome to you all and our panel speaker. Today's topic is climate change and microbes. Climate change, what is that? Climate change impacts many aspects of our lives and almost every environment on the earth. Industrial activity is widely accepted to be the main driving force behind this. The presence of microbes and their role in the climate is of paramount concern to scientists working in the field of climate science. Knowledge of this unseen majority is vitally important to fully understand their function and how they can be used in technological applications that combat climate change itself. In fact, microbes plays an important role in the production and consumption of powerful greenhouse gas, including CO2 and methane, have negative and positive feedback responses to temperature changes, and play a vital function in the regulation of ocean acidity. All of these can suffer perturbations due to anthropogenic climate change. They also have important functions in agriculture and the food web. To maintain a healthy global ecosystem, microbes are vitally important. Understanding the complex interactions of microbial biomes with higher organisms, especially plants, and how these communities of microbes can be affected by climate change is therefore critical and are also an increasingly important area of research. Today, we have our panel speaker, who is a distinguished personality in the field of Chemical Engineering Division, and particularly in this field of microbes and climate change. Let us join together and explore much of this topic. I hope you will enjoy this session, and today's deliberation will be in a graceful manner. So I would like to let us collect more information in this area and be concerned about this climate change and how to preserve this. And finally, I once again welcome you all. Thank you very much.
Thank you, Dr. Das, for your nice and hearty welcome address to the members of the audience. I now request Professor Dr. Mrs. Shilpa Tripathi, Chairman, Chemical Engineering Division Board of the Institute of Engineers. Mr. Shen, Dr. Tripathi, has Dr. Tripathi joined?
Not yet. I requested her to join, however.
And our Vice President, and CATE Chairman, are they joining?
No information till now.
Okay, so I believe we should go for hearing the lecture from our eminent panel speaker. Before I request him to start delivering his speech, I would like to say a few words about on his brief introduction. Professor Nitosh Kumar Brahmo, he has been a very distinguished academician in the fraternity of chemical and biotechnical engineering. He has been, after graduating in chemistry from the University of Calcutta, he has done his higher studies in Germany, Max Planck Institute, and he has served in the Indian Institute of Technology, Kharagpur, as well as visiting lecturer of the Institute of Genetic Engineering, Madhumram. And he has been a pivotal part of the Chemical Engineering Division of the West Bengal State Center of IEI, served as convener and chairman of the Chemical Engineering Divisional Subcommittee, and last but not the least, he is the immediate past honorary secretary of the West Bengal State Center and presently member of State Committee and also the chairman of Chemical Engineering Divisional Subcommittee. And he has contributed in many significant ways in the field of biotechnology, biochemistry, and genetic engineering. So today, as I have mentioned, that it is a very unique topic because climate change, it is normally linked with, it is a common perception that it is normally linked with the environmental issues. And it is also a common perception that climate change is concerned by only the environmentalist. It is not in that way. Every engineering discipline and as well as every fraternity of professionals are linked with the effect of climate change. And we would like to hear in some of those areas from our today's eminent speaker, Professor Nitosh Kumar Brahmo. So I now request Professor Nitosh Kumar Brahmo to kindly deliver his address. Over to you, sir.
Thank you, Engineer Oniman. I'm very much glad to hear your submission in that respect regarding the climate change microbes, as well as my professional's movement, starting from Calcutta University to Technical University, Berlin to Max Planck, and come back again to IIT Kharagpur, and then to Institute of Genetic Engineering. Anyhow, I was very much keen to understand about the microbes in that respect, not only in the infectious world, but also in the environment. Can I have the slides? Yeah. So this is my topic, and I must say that it is very difficult to understand first the correlation between climate change and microbes. But the thing is that I'm very much sure about our future objective in that we are believing on we are believing on the 3S. We have today the world 3S problem: smart, sustainability, and soil. Now, if you think what is the limit of smartness, then I believe the microbes are more smarter than any species existing in the world as well as we saw. The human beings are not so smart as the microbes. And then the consequence is that the sustainability. Now, what is the sustainability? That we are all very much aware about the sustainability, and we are always running behind the sustainability, and we want to establish the sustainability, the concept in all aspects of our human life as well as the activities. Then come the soil. Why? Because that is the point where the microbes are surviving in enormous, what you can say, quality, quantity, and as well as environmental acceptability, where water, soil, and air, they have searched, or they are taking their survival environment. Now, the very important aspects of the soil. Why? Because on soil, we are living on soil. We are seeing the plantations on soil. We are seeing the forest on soil. We are also seeing the technological innovation as well as the development in industries, as well as multi-story building and roads and whatever it might be, the human movements and survival. The reason to discuss the topic as the most important issue of the present world is that, especially India, that last 76 years of our independence, we have never thought about the existence of microbes and the climate change, which could be enormously effects on our life. And the microbes, the immense unpredictable power that existing along with us, they could be our friend and they could be also our enemies. Now, the question is very, very important. How climate changes are related is a big question. Global warming and climate change. The global environment, we will say about the global warming, the first, and side by side on the basis of warming, the change of climate. We consider the presence of microbes only when the infections are spreading in the society. Then we say, so be careful. There is an infection. You should not go there. You should not talk with that people and so on. But we never thought about that. The powerful attitudes of that microbes. Why microbes? Because it is only seen under microscopical level. The size is 1 μ As you know, the nano is considered as 10 to the power -9 meter, and where the microbes are considered as 10 to the power -6 centimeter. So basically on that process, the micron is not visible without microscope. As you know, the history, how the microscope was developed and how the microscope has been enormously supported the engineering side as well as the as well as our living side, with the expansions of the power up to electron microscope, scanning electron microscope, where the particles as well as the microbes can be seen larger, and you can also visible. I'm coming. After the discoveries of the DNA double helix by Watson and Crick, the real revolutions in the human system started, both in engineering as well as in the biological aspect, animate in inanimate. And based on that, our medical systems is also being oriented, and we have given the lot of opportunity in the bioprocess systems, fermentation process, and pasteurization, and come back why the name of pasteurizations or pasteur are coming. Both pure and hybrid natures of engineering predominated the human society. Slowly, we have seen from the pure system to hybrid system were more compatible in our social system as well as in our environmentally friendly process, so that where we can say climate change can be reduced or climate change can be controlled in that process, as well as the global environment. Reason to discuss the topic is a continuation. Reason to discuss the topic as the most important issues of the present world, the continuous. Pandemic recently in 2019 has proved how human beings are still remaining helpless in the front of corona. Fail to trace their mutational variants, COVID-19 to corona, Omicron to SARS, MERS, and monkeypox, etc. variants. They're transmitting, adhering, and infecting nature. They're killing millions of innocents. Even the Germans, arrogant Germans, who never believed about the others and what you can say cooperate, who killed and tried to kill many innocent scientists and so, prove that they think the best and do the best of all science and engineering, become helpless in the front of corona. So very, very interesting. So it has proved that corona is more smarter than Germans and whatever, the stupid people who are not sharing the global aspects of change. To recapitulate the discoveries of Professor Louis Pasteur, pasteurization, the rabies vaccine, and fermentation, scientists realized after corona and unpredictable power of microbes and how human beings are still remaining helpless to realize the microbes and climate change, including ice melt and increasing global warming, CO2 emission, and greenhouse gas are considered as the main culprit of unsustainable climate change. And increasing population and pollution, global warming and climate change around us, the need of technological innovation, converting all Greek technology to need technology to share our comfort, ego conflicting power, and destructive human relation. We have to mitigate CO2 by algae and amine-based CO2 reaction to make main fertilizer, ammonium carbonate, and whatever climate change, to global warming and ice melt, both that directly, indirectly influence the soil microbe. Now that questions of soil is coming. And their metabolic activities at a slow enthalpy. Now the physical chemistry, as you know, the entropy, enthalpy, everything in the reaction mechanism is becoming important, whether it is animate, whether it is inanimate, irrespective, you have to consider about the molecular, what you can say, environment in the form of entropy, enthalpy, and major reactions, delta G, based on thermodynamic animal and inanimate reaction. Now the question is very important. Why we are not seeing the microbes? Why we cannot see in the visible eye? Because of the size. Mainly the bacteria is one micron. Micron, 10 to the power minus 6 centimeter. Now you come to the virus, which is 10 times less than the micron. That means it is coming to then towards nano size, there's 100 nano size or to 1000 nano size or less. So now it is also true that we cannot see them, or we can't see in our normal eyes. We have to take the instrument, that is electron microscope or compound microscope, which can give you the presence of microbes in water, in soil, as well as in air. That the questions again come, why corona was so clever? Because it was transmitted through air, and it was transmitted to 6-meter distance of the patient and the healthy. And our very important mechanisms of our respiration is the lung, and that has given the opportunity to grow these virus in the lung alveoli. It has a pointed কোথায় না পয়েন্টারটা ছিল তো আমাদের এই যে this is এখানে দেখাচ্ছে, these are the virus and this is the bacteria is the 1 micron, and this is bacteriophage which can only attack the bacteria, and this is the coronavirus which can actually attack the lung alveoli, and this is the what you can say statistical variations, or so-called statistical calculation in that respect, that if I have 100 virus, it might be possible that only 1 virus can attack and can enter into the cell, and so on. So these are the coronavirus, and these are the bacteria. The size has been explained carefully to the literature, and this size and the spikes are already being known to everyone, and so on. Now I'll be moving to real life, where I have spent 30 years, so more than that, or so called. How to understand why these microbes are actually being propagated. It is not said that as soon as they will be entering in your body, they will infect you. It is said that they must have to survive first in your body, then they will start to colonize, then they will start to invade, also spread the toxin from the body, then they can move to a part where you will be infected, also you will be looking as a patient, or some will not be infected in that respect because they will not adhere, or they cannot not adhere. The same philosophy is going also to corona, the same philosophy also going to in the environment, that they will attack some of the host which can be animate, which must be animate, and can also be inanimate in the respects of other microbial infection in the globally so-called corrosions of metal, damaging of the historical monuments, and so on. So that this is a long process of the bacteria is other sides, which is not directly infected with the environmental change as well as the climate or environmental change. So now you can understand where the possibilities of the microbial involvement in the climate change are remaining with the soil. That means soil, if you can see also the polluted soil, the plant cannot grow. But the very pure soil, you can see very good plantations can make, and the fertilizer can be used by fertilizer, whatever, where the microbes will be also involved to utilize the biofertilizer. That's why the question also came, the chemical fertilizer to convert to biofertilizer. Now, the most important aspects of our global warming is the CO2, that is the main culprit, which comes from industrial area, where the industrial area is also associated with our multi-story building system, which produces thermal activity, increase the thermal activity because of the sun rays. The sun rays, the global warming, the main aspects of the sun rays, which should not be absorbed and spread that thermal effect to the human activities. And in the, what you can say, constructed or the cement constructed building, they absorb thermal. Recently, we have also seen that the lectures on the cement activities and how to reduce the thermal absorbance in the cement activities by Professor Ajay Roy, and how this can be manipulated by some kinds of nano technological development, where there's a thermal capture as well as the cement activities can be increased. Anyhow, so you say the microbes are moving everywhere, and we can only see them when we are affected. So long we are not affected, we don't care these people. So, but they are caring you, how do you live and what's the environment you like. That means, again, come to back to the cycle, the CO2 and NOx, nitrogen oxide, and other sulfur dioxide and all, whatever it might be. So you can see that the CO2 is the main culprit for which we are struggling very much to reduce the global warming. Now, how to understand that they are individually depend in the laboratory? So we can see, we can need a electron microscope, we can also have a nice laboratory to observe all the steps, as I've shown here, steps involved. And we must have some engineering development of the fermentation process. So let's move in that way to the next slide. What the cycle is actually existing. Methane is another culprit, means less global warming supporting, CO2, microbial biomass, and plants, carbon dioxide. Again, you can see the top, the carbon dioxide is one of the most obnoxious, the components which must be reduced from all aspects of our engineering development as well as the biological development. Animals, plants, and human beings. These are three living systems for which we are very much aware, and our world is existing only on the basis of our existence, because the world cannot also be responded as a non-living planet. Planet considered with human beings and animals and plants is to be considered as a living planet. Otherwise, the other researchers is searching how these planets are existing in the cosmic region, and we are actually being sharing in future so that our planet, our Mother Earth can survive longer, sustainable, more longer and sustainable. So this mechanism has to be very much accustomed by all scientists, how they could be correlated and what is photosynthesis, and the photosynthetic way we can absorb the CO2, that is the carbon dioxide, and the plants is the algae, photosynthesis is algae, and the microbial mass. That algae can be utilized both for the oil, that means in the biofuel system, as well as in the fertilizer, in the soil macros to activate, as well as our health system and planetary system. Now, this is again repeated in that respect, the soil microbes, CO2, and CO2 is being again captured by the plant. They are the photosynthetic way, they're sharing oxygen, the soil organic carbons, and microbes that giving the residues, and so all these things are correlated, and it can be utilized in the basic way of our survivals. And any misunderstanding in that process, then that will be again a challenge to climate. Because if the CO2 is increased, then global warming will be increased, and the global warming will affect the ice melt. The ice melt will develop the water level, and water level will give you again the flood, and the flood will spoil all the soil macros, all the plantations of the city. As you know, from the childhood, these are being taught that we should not have any disasters as earthquake, flood, and all these things. But they are also correlated with that cycle, that to be understood in that process. Importance of microbes is that it is well known that atmospheric concentrations of the carbon dioxide and other greenhouse gases have increased markedly as a result of human activity since the Industrial Revolution. That the question of Industrial Revolution till 2021, it was to develop mostly inanimate properties, metal, polymers, chemicals, whatever it might be. Now, after 2021 or 2019, people started to think whether we can make more animate properties. But the question is, the animate properties and the components to use is very difficult. So then the scientists started to think about the hybrid concept. And in that hybrid concept, the human system observed that the nano system is also very important. Because of the nano, due to the size, the surface area of the nano are being used, the molecule, in that respect, they can be utilized in all aspects of metal and cell or animate and inanimate environment. Whether it is in the medical aspect, whether it is in the activities used in everyday's life. For example, you can see the human lives started in the Roman Empire. They used to drink either in the gold cup or so-called or any aluminum, so-called the silver cup. Why silver? Because the silver nanoparticles and the silver gold nanoparticles are very, very important to reduce the microbial growth. That means they act as toxic component of the microbes. So they used to drink the alcohol, which is not to be fermented and will not affect the body. So the history is shown us that how silver, gold, and copper nanoparticles are very important, including the nanoparticles of other metals combined as a hybrid nano component to increase the flexibility of the nano components, or to increase the protectability of the macros, etc., etc., etc. So it depends on the research. It depends on our attitude, not to copy, but to see in practical life how they can be actually utilized in our society. This is the important stage that we have to see smart soil, soil, smart soil, and sustainability. That means not only by the process, superficial understanding of engineering and science, but also introduced to inside the activities of the soil and the sustainability and the smartness. It is perhaps less appreciated that the natural and managed soils are an important source of zinc or atmospheric CO2, and that primarily as a result of the activities of the soil microorganisms. There is a soil derived respiratory flux of CO2 to the atmosphere. That means soil is working and as the respiratory environment of the system, where they will flush all the CO2 and they will deliver the oxygen, fossil fuel emissions as one of the factors. Therefore, the small changes of the soil carbon cycle could have large impact. So, you see, therefore, small change in the soil carbon cycle could have a large impact on atmosphere CO2 concentration. You see, very interesting. That means the soil is a very, very important part of our climate change. And why? Because of the microbes existing in the soil, which will participate and to release the CO2, etc., etc., etc. We discussed whether applications of this technique can provide the information required to underpin the management of the agro-system for carbon sequestration and increased agriculture system. It is one of the very, very important aspects that nowadays the algae culture in the Western world as well as in the developing world will use. China has used most of the microalgae system to capture the CO2 on the side of to produce a lot of what you can say energy, fuels as well as the foods for the developing world, because algae, spirulina, one part of algae can be eaten by the developing world if it is managed for the fooding system. So it is information, it is this information that is required to inform rational manipulations of the plant soil system. So you see, there is a correlation between the plant soil and the CO2, and that system is managed by the microbes. You can see in the journal, The Science of Food and Agriculture, published by John Will, and you can be more associated with that. The cause of climate change, as we see, we need more to capture the CO2. We need more the plantation process where the CO2 can be captured. as you see that CO2, NOx, and all these things are coming out from the industrial belt, as you say, how the mushy land, we see that where the land containing the agricultural plants, they will be absorbing CO2 efficiently, and more it will be reduced, more the CO2 will not be absorbed, etc., etc., etc. All these things you can manipulate, all these things you can also explain to the literature as well as the published your concept, that these things will be continuing till the matter will be concentrated and is established that CO2 should be considered as a main culprit of our climate change as global warming. Now, the same I have to repeat, the how ammonia, nitric oxide, NO2 nitrous oxide, and NO3 nitric oxide, etc., N2, all are correlated with nitrogen fixing bacteria, that is so-called algae, and worm, earthworm. Darwin said once, the most important worker in the world is the water, means a kecho, and that kecho contains also a lot of microbes in their stomach, as well as their saliva can damage all types of toxic product which is not means lysed by other enzymes and so. Microbes in that respect of the kecho and earthworm can be considered very important worker or survival microbes, or so-called helping microbes to our survival aspect in the world. So this is the natural moral and ethics is also being discussed in the aspects of our what you can say ignored, also ego conflicting attitudes of the global human system, and how the same thing is ice melt is been coming together. The total amount of ice lost by the Greenland and Antarctica from 1992 to 2018 was enough to raise sea level worldwide by an average roughly 7/10 of an inch, 4.5 by comparison. Global average sea level increased by about 3 inches during this period. See the sea level indicator. So this is really we have to think about the climate change. So-called, it is not my version; it is the versions of the global scientists and all over the world who are actually motivated to war, who are actually forced to war. So and so, all these things must have to think once again. Should we do that? Or should they come forward to make world again in that level to share? Means we are not sharing. Everyone wants to be the top than the other one. This is not possible in the present world. If you be really smart, you have to share your smartness for the sustainability. If you be sustainable, then you have to again share your sustainable concept to the development, through soil, through technical, through everything. So this is the cycle that no one can come out again for the 50 years at least. So this is the system everybody knows, the consequence, the food, health, education, accessories, the climate change, how can affect. So the social system, all are correlated, all are discussed, all are shouting to say, no, we have done the best and we have not done the best. So this is my research to understand how these microbes are actually be smart. Why they are smart? Because of the genetic level. Now I'm coming to the gene. That the genes, all of the planetary system, all the living planetary system, been controlled by the genetic molecule. When you say the inanimate, then the inanimate, the electron movement, electrons and the nano movement is controlling that the process. Where in the animal system, our gene is the main, which you cannot avoid. Whatever you like to do, your gene will respond again to our activities. So with that, I have to say something about the microbes. So 1 microns, whenever you see in 1 micron in electron microscope, then it will be there also. And you can see the surface antigen, which you cannot see, never you can see in the electron microscope. These properties are remaining. And again, you can think how they actually use in the pathogen level as well as in the normal level. So every time we are taking the microbes in our body, we are respiratory systems taking microbes in our body, and we are actually giving a lot of opportunity to develop with that surface antigen to utilize. Means this surface antigen, when you extract from the surface, you can see electron microscope. These are the properties, and these properties are varied from microbes to microbes. Interesting. Why they are again varied? So 1 micron size, and they have nano size of the thread-like structure. How this nano-sized thread-like structure can be utilized in our medical science. So I'm just shifting short to the utilize from that microbes, which are friend as well as enemies, can be varied in a different, what you can say, phenotypical. Pheno means whatever you see in the normal, and geno means whatever remaining inside the system can be calculated. So 30 years or so more than I've spent my life with that. It is not so easy. It is a very, very interesting. Why corona vaccine is still not being established? Because of the change of these molecules in the form of spikes. We have heard the spike molecules are attaching the lung alveoli, and that spread after attachment. Before attaching, no. After attachment, they spread the RNA molecule inside the alveolar cell and multiply in the RNA molecule to multiple cells of the corona, and then burst, and that affect the corona patient to die, and so on, so on, so on, so on. And according to the infected molecule which is coming out from that body, infect the others. So this is the philosophy that you understand very good. But the thing is that my observation was why they do so, how they do so. But still then, I have not found out any solution. I'm trying very, very concerted way to get some result, but it's not possible for me to understand the relation. You see, here enteropathogenic, enterotoxigenic, enteroinvasive, all these things is being slowly fixed, and accordingly we can also put the medicine antibiotics Now you see that word antibiotics, which used at that material time when the Pasteur was 100 years ago observed, at that time the vaccination process in the rabies was found. At that level, when Fleming discovered the penicillin, in that system, and today since the colonial system has been changed vigorously in the concept of the surface antigen means, these the surface, what I'm talking, they're varying according to the mutants. Now, why they are varying? Is it that from the outside that influence to do, or it is inside? Yes, it is coming from the inside. That means in the plasmid, I'm not going to say anything regarding that form and that form because you will not understand now. But you can understand if you at least spend day and night to search about these properties, to extract these properties and correlate according to their infective nature, and in that way you can also develop to you can also try to develop the concept of vaccination. Why vaccination? I'm coming back to the next slide. Why antibiotics? What is the relation? And why antibiotics can also influence the global warming as well as the climate change is also being correlated. More antibiotics means more the soil will be polluted. More soil will be polluted means more environmental friendly plants will not grow, etc., etc., etc. And why vaccination? Because it remains in the memory, and that will protect the adherence, mean microbes of that type of species or that type of origin will not affect you. Now I'm coming to that. You alone. Hey, Shupyo. Shupyo? No. Yes. Now, you can wonder about that, the paper. It's it is now showing here. Yeah. Nobel Prize for Watson and Crick, who discovered the double helix, who discovered in 1953, in Nature published in page number 25, or date 25th, 1953. And that has changed the whole climate of the social system, main medicine, polymers, which is very much essential for the human system to manipulate and to develop the concept of vaccination. The gene, the molecular structures of the gene that has developed how to change the medical applications of antibiotics, as well as how to actually treat the patient against the antibiotics. Antibiotics is actually an external philosophy of the chemistry which developed lactam ring to associated component to kill the microbes. True, very good. But after that, what that antibiotics will do? Now, Watson Crick showed how the gene can be manipulated in the process of the cloning, in the process of the expression, in the process of the environment, in the process of what you can say, the climate change. We have to survive both in the industries as well as in the nature. Otherwise, it is not possible because of the population which is growing exponentially. Accordingly, the pollution, etc., 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 etc. All these things are being discussed rigorously in every time, everywhere. Now, the question is genetic engineering. The word is very fantastic to hear, but to do is a very, very serious and very, very uh, costly aspects of the handling of the microbes, hybrid and wild type, to differentiate them and to be patient to work with these microbial properties, not superficially, just to go in the, what you can say, in the diagnostic process. Nowadays, very interesting. We have all computerized. We have all computerized to get the result of the sequence, to get the results of the analytical, what you can say, correlations of the precipitation, whatever it might be, and to say, yes, this is the culprit. But whenever you are actually going in the deep, you will see that culprit you have captured, that is the microbes, that doing all a patient ill or kill the patient. But after 2 or 3 days, or after 2 or 3 months, or after 1 year or 2 years, whatever it might be, if that patient comes back again, then you think, why? I have already treated with antibiotics and he was okay. And why a patient is again being affected in the same microbes or same? That question only be clarified by the genetic variation that known as transposable jumping gene, mean a strain which is remaining A, slowly becoming B in the effect of climate. At the same time, how whenever they are becoming more vigorous, or so-called as the corona, how they could be very quickly changed within the system, existing in 1 to 2 months or so, 1 to 2 days, to a new component or new what you can say, mutant. That is only possible that a gene is jumping inside the molecule that known as transposable. While jumping, it is remaining in one side by conjugation, so by mutational movement. It can jump, or it can rise themselves from one place to the other place and be integrated. That's why it is a transposable. Transpose means one place to another place, and that defined also with the antibiotic development, with tetracycline, chlorphenicol, etc., 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 whatever it might be, that with the levels of TN, mean transposable element, confined or so-called integrated with the insertion sequence. Flanked means here is the TN and the flanked insertion sequence, which will attack in the new DNA molecule. So in the molecular biology is a vast area. After Watson and Crick development of the double helix, a lot of development in that direction has been developed. At the same time, it has been also implemented in our environment with the microbes, that how they could be very rapid, or they could be very
I believe Dr. Brahmo, Professor Brahmo is disconnected and he will be joining soon. Just please, I request all the members of the audience to be here. And just it is because of a technical glitch, I believe. Mr. Sen, Mr. Kingchuk Sen, are you there?
Hello, engineer Anirban Natto. Is it audible?
You are audible. You are audible. But actually, has been disconnected due to
Yes.
some issue with network. But he will be connecting right now.
Okay.
Okay.
Hello, Mr. Anirban.
Yes.
I think there is a technical issue.
Yeah. Mr. Professor Brahmo, his laptop actually it has been out of power, so he is now connecting. Just within a minute, he will be online.
Okay. All right.
Meanwhile, I request all the members of the audience to kindly be online. Yeah, Professor Brahmo is again reconnected. He has been reconnected, and he will be continuing his presentation.
Sorry. It is not my fault of the connections as well as the internet.
Are you appearing from institute, sir?
Yes, I'm just connecting. Just a second.
Yeah.
Yes. My presentation. Yeah. Can you see my presentation?
Yes.
Yes, we can see. We can see Professor Brahmo. Can you please go to the slide where from where you got disconnected?
Yes.
Yeah.
Just hey. আমার ওই স্লাইডে যাও আমি বলছি কোথায় Yeah, from there. Yeah. Well, that I started to explain, and somehow we were just disconnected, and we tried to come back again in the form so that I will go to that the paper image that is double helix discovery 1953, and on the basis of that we were connected. Also, we have come to our present world with biotechnology as well as polymer science and material science, whatever it might be. Everything is correlated with the double helix. And the Kishera hello, the Kishera huh? So industrial revolution is essential. That we have observed how the industrial revolution started from the quantum mechanics to the nuclear engineering and so on. Then the polymer engineering, and the present world is the microbial, also called the microbial world, that we have to actually correlate and to optimize the situation. Now, I have already discussed. Hello, there is a noise. Anyhow.
Yeah, Professor Brahmo, I think there is some mobile phone is placed near
no,
the.
My mobile phone is closed. Everybody is here is closed. Somewhere.
Yeah, there is some echo is coming. Anyway,
okay,
you please,
no problem.
please carry forward.
Okay, I have understood now.
Yeah, please carry forward.
I'm just moving. Okay, so what I want to say that the transposable jumping gene, and on the basis of that jumping gene, the present world is suffering with the different microbial infection and pandemic and all type of infectious situation. Anyhow, that is the things that is correlated with the microbes and the climate change. The climate change is because of they are affected, and because এটা তো এটার ভেতরে যত তাড়াতাড়ি বলছি তত more you are infected, more you will be also dependable to the climate, and more the climate will be disrupted or so-called disturbed according to our immune system. I've told that some adherence and immune system will be more important in your existence and survivability, as well as our sustainability based on our immune system. And some points I'll be informed to say what is the important issues of our sustainability is that we should be resistible to the environment. What's the word of resistible? Resistible means our immune system must be grown according to the climate change in such a manner means we must be more adaptive to the system, adaptive to the environment, adaptive to the climate. So based on the adaptability, we are more sustainable. So you see the correlation between the sustainable and adaptability. Based on that system, I've just described very small things by and genetically engineered and the wild type. This is the that is genetically engineered, that is a mutant, and that is a wild type. How they are, if they three are introduced in our body, how they will be responding in our human system, the automatic, the immune that is generated in the form of innate immunity and adaptive immunity. Means vaccination is the process where you are taking inside your body some kinds of hybrid system which the antigen developed by the antibody and so will respond in a that you will not be infected in future any kind of wild type or so-called the mutant that has been generated in the process of the climate. The climate change and the immunity are correlated. Means more the climate change, if you not be adapted to climate change, your immune system will be unsustainable, and that means you will be infected. So that process I have developed in the lab. So how the immune system can be developed, and so how the mice can respond the same result that is actually being carried out with the hybrid system and etc. So now we see the what is the actual the electron microscopic aspects. If you see that that is the molecules that has been electron microscope, if you put it in the membrane, so etc., all these things has been disturbed through the and the systems of our presentation system. This is the statistical interpretation, a very clean manner how CO2 emissions are actually being reduced during the corona period, and how that's being again involved in future. So this is actually the experimental methods that we have applied in the process to understand how the climate change, how the thermal effect, so climate change, humidity and everything affect on the molecules or so-called microbes, their growth process, and etc. So we can say that this is a very, very important area to understand the climate according to their change, according to their molecular change to the environment, and we must have to respect also the environment that is being associated also for responding to the experiments. So I thank Engineers India, West Bengal State Chemical Engineering Division to organize the webinar climate change and macros to ensure the importance of the climate change and the role of macros in such important issues. As chairman of the Chemical Engineering Subdivision, I also thank my committee, especially the Vice Chairman, Shudi, Professor Homolish, Professor Roy, Professor Council Member CG, and then Dr. Vijit Ghosh. I also thank Mr. Shumi, Bhorababu, Shupio, Purjun, Shapun, and others, their wholehearted support to arrange such fantastic webinar. Thank you very much. And if you have any question, I'm ready to answer.
Yeah, thank you, Professor Bromo. Already we have received a question from Mr. Wesley Pereira. Mr. Wesley Pereira, that he has asked that, sir, could you share any case study highlighting the importance of microbes in creating a positive impact or reducing the negative impact of climate change on agricultural productivity in India?
Yes, algae. I will say that please, everybody should move towards algae culture, algae biochemistry. Why? Because of the photosynthesis. Because we cannot avoid the sun. And our friend sun, can help us also to reduce the CO2. And the CO2 is being captured by only algae, which is go in all directions of the plantation process, in the medicinal process, as well as the fertilizer process. Algae culture, algae development should be taught to all university, to all students, and it is very difficult. It is not so very easy to develop algae microculture as well as macroculture easily on the surface. It should have some specific technique or so-called adaptability to make algae to grow, because if algae is not properly adapted with the environment, it will not go fast. And if it is adapted once, then it will go it will be very rich with the algae culture in the direction of biofuel, in the direction of fertilizer, in the direction of solutions.
I believe, Mr. Pereira, you have received the response from our eminent speaker. And what I could sum up from the presentation of Professor N.K. Brahma, that his lecture imparts a focus on the effect of particularly reducing the effect of climate change on the soil, and microbes can play the very significant role on that. So I have a query to Professor Bromo, that effect of algae, as you have just now mentioned, effect of algae on agricultural productivity, or per se largely on the soil. So in different part of the world, so how it may differ?
Yes, very good question. Because algae is an eukaryotic system. It is a microbes as well as in between plants and microbes. It is an eukaryotic system, and it is a to participate in the photosynthesis. And because of the sun everywhere in the world, and these microbes, or so-called these algae, can also be in the winter region, summer region, as well as the humid region, similarly be affected if that the sun can be controlled on that process. Light.
Okay, so that means that climate change issues in Arctic or Antarctica region,
Yes,
and climate change issues in India or Australasia, so that algae culture can produce same impact.
the same effect, but you have to develop the algae to get the effect in a particular environment. You have to develop in that particular region where you are considering it is Australia, it is Germany, it is USA, it is India, and etc. And in India, it's the cold region and the summer region and humid region as well as rainy region, whatever. So this is a very important that the algae understand us according to the support light. Main issue is the light temperature, humidity. These are the three issues in algae are very important.
Excellent, Professor Brahmo. Now, I would like to focus on a bit shifted area that as for the last 2 years, the entire globe has confronted with the pandemic. And it was at the beginning of the pandemic period when there was a more or less worldwide lockdown. It was saying that the climate has been improved with more clear sky and less pollution. And but the other hand, because of the restriction of the industrial activities, but on the other hand, the effect of a virus, it has practically devastated the world. So this conflicting, as you have very correctly mentioned, that mitigation of climate change is of importance as well as the industrialization and development. So how with the utilization of algae culture or microbes, how would you propose to draw a line between the development and sustainability?
Very good. See, we have three keywords. One is the pandemic, other is about sustainability and survivability, whatever. The thing is that we have to survive. We have to face also the viruses. But you have to optimize. How do you optimize it? You have to optimize in such a manner so that our everyday's culture will sustain, and we are protected. We are protected somehow by these culprits. How? The protection can be done, I've already said, by vaccination process. That you develop what I am always dreaming to develop a universal vaccine which can actually protect the human life from all types of culprits. It is a one item, vaccination. Other item is a technical protection. How? Masking. The best way, even today, is the masking means you are not protecting only corona. You are protecting all viral, bacterial, and infectious items from your body. At the same time, if you think your body is immunized against all culprits, then you will be little bit relieved. But if you think that my body is not immunized, so you will be a little bit more careful to protect that invading particle, either as a corona, either as a bacteria, either as infectious any items.
So you have now harped upon a very crucial point, that use of mask, and for the 2 years that mask has been an integral part of practically the human civilization. But
sure.
For a
I emphasized that even today, if you come out from the house, even in the house, if you sweep any dust or anything, you wear mask. Mask is one of the fantastic support to everyone against any infection, whatever thing, provided that you know that infection, and provided that you don't know, don't test it, mask, inevitable.
Now, sir, from another school of thought, it says that for a country like India, which is having predominantly the pollution level is much higher compared to the developed nations, the usage of mask has significantly reduced the immunity of the common people, because Indian people were not accustomed to using masks like people of citizens of Japan or Europe.
They should be enforced. I believe today, even today, that all workers must wear masks to work before you go in the work. That is one. I believe today, even today, with all type of concept and whatever, that I must go more with the mask, even if I sweep or even if I clean my room too.
But that school of thought, there is some advocating that this usage of mask in Indian scenario, that is somehow creating reducing the inbuilt immunity system of Indian mass. So what is your takeout on this?
I understand. But immunity and muscle, there are two different items, two different concepts. You be immune, then you can also go in the slum. That is slum. If you think that I don't know all the enemies of that culprit area, I must wear mask. That means you are immune, but you don't know a new place where the new culprit is waiting, which is not been recognized by your adaptive immune system, means vaccination.
Okay. So we are having another question from Mr. Wellesley Pereira. That what is the impact of land and environmental degradation on the climate change scenario?
Well, it's a very vast question, and cleanliness and the soil and the environments are coded. If you really think that we have to be, our country must be sustainable, from your working table to the slum must be very clean, trying to be very clean. And that will affect my seepage of water by using the soil, means by working and by living. Is a attitude that you love your country to make the country, by making the country very clean, and in addition to that, your attitude to cooperate must be very high. It is not say that our technology will help us or our society without cooperation, without giving any instruction properly, friendly, and collaborative.
Yeah, thank you, Professor Brahmo. And I believe there is no more question left in the chat panel. So I would request our Honorary Secretary, Professor Dr. Raju Bosak, to kindly deliver the vote of thanks.
Well, Engineer Anirban Datta, is it audible?
Yes, you are audible. You are audible.
Okay. So first of all, I believe this is the first time a webinar is being arranged from Chemical Engineering Division, West Bengal State Center. So I must congratulate Professor Brahmo for taking the initiative to arrange today's webinar from Chemical Engineering Division, and I encourage more and more webinars should be done through this West Bengal State Center, so that we can educate, we can enrich more through various types of knowledge. Thank you, sir. Thank you very much.
Thank you very much.
So thank you, Mr. Anirban Datta, for giving me the opportunity to propose the vote of thanks. I must thank all the distinguished participants in this technical webinar. on the theme climate change and microbes, organized by the Chemical Engineering Division, West Bengal State Center, IEI. At the outset, I convey my sincere thanks to the panelists, Professor Nitish Kumar Brahmo, FIE, immediate past honorary secretary of State Center, IEI, and the chairman Chemical Engineering Divisional Subcommittee, West Bengal State Center, IEI. My vote of thanks also goes to Dr. Nimal Das, Chairman of State Center, IEI, Dr. H.O. Thackeray, President, IEI, Mr. Ramil Mahadev, Vice President, IEI, Professor Dr. Shilpa Tripathi, Chairperson, Chemical Engineering Division Board, IEI, Dr. G. Ranganath, Chairman, Kate, IEI, and Mr. Anirban Datta, Partner and Chief Technology Officer, Messiah Engineers, Joint Honorary Secretary, West Bengal State Center, IEI, and the moderator of this program. So, my vote of thanks also to all members of the council and division board members of Chemical Engineering Division Board, all the members of the committee, West Bengal State Center, IEI, and all members of the Chemical Engineering Divisional Subcommittee, Director Technical, IEI, and his team for their wholehearted support. Last but not the least, my sincere thanks also goes to all the persons who are behind the scene and giving their silent support to make the program a success. Thank you all. With this,
Thank
we
you,
are
thank you.
concluding today's work.
Thank you.
Thank you very much.
Thank you, Dr. Raju Bosha. Thank you very much. I'm very much pleased regarding your support.
Mr. Sen, Mr. Kingshuk Sen, the live may please be disconnected.
Okay, thank you.
Thank you. Hey, এটাকে বন্ধ করে দাও।